How are you, sir? My name is Brian Manamike.
The first part was about dataset exploration. My name is Brian Manamike, and I'm presenting on my statistical machine learning assignment. As I said, the first part is about data exploration. So we had to read our data, and then we had to check the dimensionality. And after I did that, I found out that my dataset comprised of 225 rows and 2 columns. And then I had to plot a scatter plot to see how the data is distributed. And from the distribution, I saw that this was a continuous data, which was showing that R is the, which was showed that R, which was showed that Y depends on X. And hence I concluded that this was a regression problem. Number two, it was a theoretical framework. A theoretical framework, it is a design or a statistical, an underlying mathematical and statistical principles, a design of an underlying statistical and mathematical principles. So the first part was to find the function space Y. The function space Y consists of a collection of functions typically defined as the specific domain taking value in a specific range which satisfy a certain condition. So as for me, my space H was this one, was this function below, where we can see that f of x approximates y as a function of x and theta, and are the coefficient to be determined. With a function of theta and x are the coefficients to be determined. Alternatively, for more complex relationships and radial bases can be used instead of polynomial. Problem number 2b. Problem number 2b, specify the loss function for this task and justify its use. The loss function in machine learning refers to the function that quantifies discrepancy between the outcome and the predicted output made by the model. So as for me, I used f of x minus yi squared, which shows that it's the predicted minus the actual value, and we squared it. The justification was there's minimizing error, it's smooth and differentiable, and also there's emphasis on larger errors. Part C, theoretical risk definition. I used this one, how to derive it, and then I squared the error loss. I substituted the loss function and expanded the square. That's step number 4, and then splitting the integral. That was step number 5, and number 6, it was bias optimal function, where I found that it's a summation of y given x. As for my bias theorem, I used this function which showed a Gaussian distribution. Then I found that f star is equals to min x. And for linear model, this simplifies to f star equals to b naught plus b1 times x. Empirical risk, I found that it was RF 1 over n, where n is the number of the data points, and Ly f of x is the loss function that quantifies the error between the true output y and the prediction f of x. As for the problem exercise 2, I used libraries such as Caret, which means classification and regression, training, and also I used ggplot to plot the cross validation and then the empirical risk. As you can see, as the degree is increasing, both the cross validation and the empirical risk, they go down. And then I summarized that the small gap between the empirical risk and the cross validation error across all degrees implies that the model is generalizing well without overfitting. And on model comparison, on model comparison, I compared the simple and optimal, and then I found that the optimal of degree P was the one which was smooth, and as I concluded, the optimal model is the desired output for most reward application as it minimizes errors unseen. And also I managed to cheat the same output. Thank you very much. Much is included in my PDF and also my R script. I thank you. Stop recording. So I now want to put it on your YouTube channel. You stop the recording? Yeah. I now want to put it on. Must do have a YouTube channel.
Let me check. Let me check.
Can you create one for me?
Did you stop the recording?
Yeah.